Yes, dear student, now I am going to discuss very important topic and very wide topic, and I should say the topic which we talk every time, energy. But unfortunately, we people are unable to understand what is energy. Energy is a very wide term, and you can understand it like this. If I can talk, I have energy. If I can walk, I have energy. If I can write on board, I have energy. If you can play, you have energy. So that way, when you are running, you are doing something, some work in carrying your body forward or backward. When you are pulling something, you are using energy and doing work. Every vehicle, every motor use this energy and does work against some force. When your vehicle move carrying the load, that is doing work and is using energy which you give to that machine. So this way we can say how to define energy. The ability or capacity. These two terms appear same here. Of doing work. Of doing work is called energy. The ability or capacity of doing work is called energy. If you can do work, you have energy. If you can't do work, if I cannot speak, I have energy. And any dead body has no energy because the machines which was supplying energy has stopped working. So that way ability of or capacity of doing work is called energy. Since energy is measured in terms of work done. Work done. So, unit of energy is the same as that of work. Energy is measured in terms of work done. So whatever the unit of work, that is the unit of energy, and hence in MK system and SI system, in MKS or SI system of units, now a unit of energy is joule. In SI system, unit of energy is joule. I am repeating again here, small j, but symbol is capital J. It is on the base of joule, scientist. So the units which are in the name of scientist, when we write complete, then we use small alphabets. And in CGS system, it is erg. Now Actually, F system here is obsolete, we don't use, and we never talk about that unit. Poundal is the unit of energy or work there. Pound is the unit of weight or force. Now, these joule and erg are the unit in MKS or CGS system and are small, but there are particles very small like atomic size particle like electrons, protons. The energy of electron proton is not generally measured in joules. For that there is another unit to measure the unit of atomic size particles. We use to measure the energy of atomic size particles like electrons, protons, etc. We use a smaller unit of energy. Dear student, it is a problem in the mind of student. Why so many units are there? We use different units at different place just for the sake of simplicity and understanding. When some child is born, generally we say how old it is, 2 months old, 3 months old. Or then after 1 year, we say start counting in here. Now it is of 2 years, 5 years. Though unit of time is second, as unit of time is second, but we tell our age in years because it is convenient to tell. 1 year, I have told many times, 1 year, 3.16 10 power 7 seconds. So this is big number. If you tell anyone your age in seconds, then he will not understand and you cannot also tell. So these different units are used. So here a small unit of energy is used, which is called electron volt. And this smaller unit, this small unit, I should say, this small unit of energy, is electron volt. Small electron volt. And written as small e capital V. Now, how much energy is 1 electron volt? Please remember this is very important unit. And don't be careless about the units of physical quantities. Generally, now the situation is very awkward because in exam the system of filling the blank, match the following column. So students are not in habit of telling the thing or concept correctly. They hesitate to tell. For this, you start earlier. After understanding the topic, you start learning the language of the author or the teacher, and then you will be able to tell. But initially, it will be a problem for you. But give time. So, how much energy is 1 electron volt? Definition of electron volt. In class 10, you have learned the topic electric potential or potential difference delta V, W upon Q, 0. If you carrying charge Q0 from point A to B, W work is done, then potential difference delta V is equal to W upon Q0, and from here W equal to Q0 into delta V. Any potential difference multiplied by charge give the work, and therefore how define this? When, or इसे write this, the kinetic energy, the energy लिखे बस, energy gained by an electron, when it is accelerated through the energy gained by an electron when it is accelerated through a potential difference of 1 volt. So 1 eV is equal to 1 volt into charge of electron. And I think you know charge of electron is value magnitude 1.6 10 to the power 19 coulomb. Magnitude of charge of electron is 1.6 10 to the power minus 19 coulomb. So it is 1 volt into 1.6 10 to the power minus 19 coulomb. Volt into coulomb become joule. So it is 1.6 10 to the power minus 19 joule. Please remember this relation. 1 eV. I noticed in my school time when I was teaching there, still I am teacher, but when I was working as a teacher in school, that my colleague left electron volt. Why? Because by potential difference is taught in class 12. But they have learnt in 10 also. Why to forget that? Potential difference is defined in class 10. So why do we underestimate the student? They will not understand. Tell them, they will work, they will understand. But electron volt in fact become very small unit further. And even you might have learned photon of light. Light photon, ये visible light photon, has energy in the range of 3 electron volt to 1.8 electron volt. किसकी एनर्जी है? एनर्जी ऑफ लाइट फोटोन, violet color, red color. In chemistry you are taught in class 11 this Planck quantum theory, light travel in the form of small packet of energy which is called photon, and energy of photon हमने चेंज करके आया डायमेंशन रखते हुए इक्वल टू h न्यू. एक क्वेश्चन दिया था डायमेंशन में कि राइट द डायमेंशनल फॉर्मूला फॉर h प्लैंक कांस्टेंट के लिए. एनर्जी का क्या डायमेंशन ml2t-2, फ्रीक्वेंसी 1/2, तो इट बिकम्स 1/t, इट बिकम्स है ना ml2t-1 like that. So electron volt, but electron volt is smaller unit, so we use some bigger unit than electron volt, bigger unit than electron volt. There are two. Number one, kilo electron volt. Kilo electron volt. Written as K-E capital V. Please pay attention while writing. Don't write K-E-V. ये कुछ भी नहीं होता. Kilo electron volt is written here like this. Number two है million electron volt. Million electron volt. इसमें लिखते हैं कैपिटल M स्मॉल e D. and 1 kilo electron volt means 1000 electron volt. Kilo I'm telling, multiplier, you can say kilo year. The year 2000 year, है ना? When came this is called millennium year, है ना? So I read in a newspaper Y2K. I got confused while I keep on telling students. So Y2K means year 2000. Kilo means 1000. Please. Kilo means kilogram नहीं है. Kilo means 1000. And 1 MeV million electron volt. Omega or million the same thing. 10 to the power 6 electron volt and equal to 1.6 10 to the power minus 16 joule. And it is 1.6 into 10 to the power minus 13 joule. These all units are very important. Conversion we should remember. So this was something about energy which I tried to explain you. Actually, our professor told energy is a very wide vector. Oh, actor, any actor can perform the role of anyone. So energy also plays many roles, very wide term. You have learnt heat energy, light energy. I will come to this point here. So this was all about energy and its unit. Now, since joule and electron volt are very small units, then for commercial purpose, what unit do we use? When you consume electricity, that electric energy you are consuming at home, you use, nowadays LEDs and have come, which are of 9 watt and 12 watt. Initially, though, in our time, we were using bulb of 100 watt, but at that time, other electrical appliances were not used. Nowadays, there is big number of electrical appliances which you use at home. Fridge, TV, cooler, AC, and so many things are there which consume a large amount of energy, electrical energy. How to measure this energy? Okay, suppose we have a heater of 1 kilowatt. What does it mean? Or we have a bulb of 60 watt. Or we have a LED of 12 watt. In my room, LED are 12 watt. So what is 12 watt means 12 joule of energy is consumed in 1 second. If I say 12 watt, 12 watt, so it means 12 joule of energy is consumed in 1 second. 1 second, you know how much time is there? You use these devices many hours a day, and then months and years. You get your monthly bill of electricity, and you get a very good bill in your hand. Now in summer it will be, for me it will be 8,000, 7,000, 6,000 rupees. So how to calculate that energy? Then if we use this watt or joule as energy, 12 joule per second. So it means in 10 hours how much energy will be consumed? 10 hours means 36,000 seconds. 36,000 multiplied by 12, again get a big number. And when you calculate month, so it will be like that. It is to tell your age in seconds. So we use a commercial unit. और हाउस होल्ड यूनिट भी बोलते हैं, हाउस होल्ड यूनिट, और कुछ नाम और भी है ना, of energy is kilowatt hour. Kilowatt hour. H is cancelled. It is known as small k kilowatt, capital W, small h is the abbreviation. Bigger unit of energy, kilowatt hour. 1 kilowatt hour means 1000 watt. I should say 10⁻³ watt into 1300 second. And watt into second becomes joule. When we multiply, we get 3.6 10⁶ joule. 1 kilowatt hour. If you have a device of power 1 kilowatt and use that for 1 hour, then you have consumed 1 unit in 1 hour. 1 unit of electricity. This number of kilowatt hour means number of units consumed. I think the video has become very lengthy. I will tell you something more about kilowatt hour in next video.